Welcome back to absolute value function transformation. So today we're going to focus on identifying domain and range. So first we're going to be identifying domain and range using the graphs. Of course, these graphs will have their given equations, given functions. And then once you are able to understand the patterns, the rules, and the format of domain and range, then you should be able to transition on identifying domain and range with just given equations, given functions. So let me describe about domain. Domain is the x values going from left to right. So for domain, you always start with the left x value and then with a comma, and then you're going to end with the right x value. So that's how you're going to identify the domain. For range, is the y values up and down. So we're always going to start from the bottom of the graph. So the bottom y value with a comma, and then we're going to end with the top y value, the top of the graph. So that's basically what you have to do for domain and range. In this section, we're going to be writing in interval notation. So for interval notation, is a certain format we have to write because there's different notations for domain and range, but right now we're going to focus on interval notation first. So we're going to write domain and range using parentheses and brackets. And you will see the purpose and differences between using parentheses and brackets. So pay very close attention when to use parentheses and when to use brackets. So here we have two examples, two graphs with their corresponding equation. So let's take a look at the left. So here we have g of x equals to the absolute value of x minus 3 and then minus 5 with its corresponding graph. Then on the right side, we have h of x equals the absolute value of x minus 3 and then plus 2 with its corresponding graph. So the similarity between these two functions is it has the x minus 3 inside the absolute value, but on the left it has the minus 5 in the back, and then on the right it has the plus 2 in the back. So let's see on how to identify the domain range. Let's start with the left graph. So usually we start looking at the ends of the graph. So let's take a look at the ends on the left of the graph. So this one has an arrow, and then on the right it also has an arrow. So the graph, both of the sides has arrow. That means that the graph goes on forever. So we're going to start identifying domain. So remember, domain is usually from left to right, or the x values. As you can see, here's the x-axis. It goes left to right. So let's look at the left side first. Since the ends has an arrow, that means it goes on forever. So I'm going to draw my left arrow, or an arrow pointing to the left. And then I'm going to draw another arrow on the other side pointing to the right. So I'm using this to help identify domain. So since on the left side, since it's going towards the left with an arrow at the end, that means it goes on forever. So if it goes on forever, that means that it's going towards infinity. But we have to be very precise because since it's going towards the left, certain type of numbers we have are negative. So since we have infinity and there's two types, we're going to be using negative infinity since it's going towards the left. And then when we're using infinities or it's involved in infinities, we're always going to be using parentheses. So like I said, since it's going towards the left, we're going to be using negative infinity. So let me insert the infinity symbol. All right, so that's how we're going to start off. And then let me put my comma. Now we're talking about the right side. So on the right side, if you look closely, the end of the graph has an arrow. That means it's going on forever. So since it's going towards the right side, which is usually the positive numbers, and since it's going forever, we're going to be going towards positive infinity. Now for positive infinity, you don't have to put a plus sign to indicate that it's positive. You can just simply just write infinity like that, and then you're going to end with parentheses. So that's how you're going to identify for domain of this graph. Now, let's talk about identifying the range. So now, if we look at the left side, it's going up. So do that one, pick this. So that's the left side. And then on the right side is also going up. Because if you look at the graph, it's actually going in two directions. So on the left side, it's actually going left and up. And then on the right side of the graph, it's also going right and up. So both sides are actually going in two directions. But for range, we're always going to focus on the bottom of the graph to the top. So let's take a look at the bottom. Right here. So the bottom of the graph, we compare it to the y value, which is at -5. So that's where it's going to start. So since the range, the bottom of the graph is going to start at -5. Now if you look closely, it is right at the line for -5. So that means that it's going to include -5. Since it's going to include, we're going to be using bracket. And then we're going to type in -5, comma, and then now the top y value, it ties into the ends of the graph. As you can see on the both side of the graph, it goes up forever. So since it's going up forever, that means that it's going to go towards infinity. So it's similar to domain, but this time we only have one infinity. Change this. There we go. So here, since we're using infinity, we always have to use parentheses like that. And that's how we identify or write out range for this graph. So be aware that all the infinities always use parentheses. And then now for this function, if you look at the bottom of the graph, it's right at -5 for the y value. So that's why I use the bracket on the -5. Now, just because it's a number doesn't mean that it's always going to use bracket. Most of the examples in here, we will be having brackets on the number, but be aware there will be different type of problems where sometimes you're going to use parentheses on the numbers. So do not assume just because it's a number, you always use bracket. There will be other types of problems where parentheses will be with the numbers. All right, so let's take a look at the right example. So let's see the ends of both sides of the graph. They have arrows. So that means that they go on forever. So if I were to draw my arrows for the left side and the right side, so for the left side, it's going on forever. But remember, the left side of the graph, it goes in two directions. So it's going to go left and up. But we're going to do domain first. So it's going forever to the left, and on the right, it's going forever to the right. So if it's going forever to the left, then let's type out our domain. So if it's going on forever, that means that it's going to go towards infinity. But since it's going towards the left, it's going to be the negative infinity. So let me copy this, paste it over here, comma. And then if you look at the right side of the graph, same thing. It goes on forever. So towards the right, it has a positive number. So we're going to have positive infinity, or simply infinity. And then we're going to end it with parentheses. So that's all we have to do for domain. Now let's take a look at the range. So remember, range always starts at the bottom of the graph. So let's take a look at the bottom of the graph. So we see that it starts at 2. Okay, so that's where we know where it's going to start for the range, at 2. Now for the top of the graph, both sides has arrow. That means it's going to go on forever. So on the left, it's going up forever, and on the right, it's going up forever. So eventually, both sides of the graph will be at the same top y value. So since the bottom is actually at a number, which is in this case 2, I'm going to be using the bracket. And so it's positive 2, so I'm going to type in 2, then comma, and then again, the top y value of the graph, it goes on forever, so that means it's going to be going towards infinity. So we're going to write infinity. And then since we're using infinity, we're going to be ending with parentheses, like so. So this is my range, my domain and range for this graph. All right, so let's talk about the domain and range between these two functions. So if we look closely, we notice that the domains are the same. And we notice that inside the function, x minus 3 is in the same. So I would say that the similarities between these two is that the domains is the same. The domain of the two graphs functions are the same. Now, what were the difference? The difference were the range. So the left graph had the range start at -5, while the right graph had the range start at 2. So that's the difference with the range, even though that both of them end with infinity. But let's talk about the range in depth. So on the left graph, see how it started at -5? It's similar to, or ties into, this number right here. And then on the right, you see how it starts at 2, or positive 2. So it ties into this number right here. So that's a clue that's like, hey, this might help us identifying domain and range, well, particularly range, when you are given only the equation. So take note on maybe that this can help you identify range. So make sure you have this written down. Make sure you have all notes written down, especially the arrows, so that it can help you identifying where it goes for domain and range. So here we have the next two examples. So let's take a look at the equations and the graphs. So on the left side, we have k of x equal the absolute value of x plus 1 and n plus 3. Whereas on the right, we have m of x equals the negative of absolute value of x plus 1 and n plus 3. So when we're comparing these two equations, they are almost the same, except for m of x, it has a negative on the outside front of the function. That means it's going to be a reflection. So let's look at the graph. So as you can see on the left, it's a typical absolute value graph, but when it's reflected across the x-axis, now you can see that the graph is going downward. So we're going to see how it affects the domain and range. Let's start off with the left examples. As always, we're going to identify the ends of the graph. So as you can see, it has arrows at the very end, so that means it's going to go on forever. So let's label our arrows. So let's take a look at the left side of the graph. So on the left side, you can see that it's going forever towards the left. In addition, it's also going forever towards the up. So as I said before, the left side of the graph is going diagonally, so that means it's going left and up forever. Now let's talk about the right side of the graph. So again, same thing. It's diagonally going up, so that means that it's going towards the right forever, and it's going up forever. So it's going in two directions. So there's my arrows. Now we're going to use the arrows to help identify our domain range. So let's do domain first. Now for domain, we're always going to start with the left x value or the left side. So if you look, the arrow is pointing towards the left forever. That means it's going to go forever towards infinity. But remember, since it's on the left side or it's going towards the left side, it involves with negative numbers. So in this case, since it's going forever towards the left, that means it's going towards negative infinity. So negative, and let me bring this infinity. So there's the left x value, so negative infinity, and then comma. Then on the right side, you can see that the arrow is going towards the right forever. That means that it's pertaining to the positive number, so since it's going forever, it goes towards infinity. And then close parenthesis. Now, what I didn't mention earlier is that parenthesis is to symbolize that since it's going towards infinity, that means that it won't reach infinity. It can go towards infinity, but never reach it. So, in the event, which I mentioned before, in the event, some problems where some numbers will have parentheses in domain or in range or in both. So it's just basically saying that the solution or the graph, it can go towards that number but can never reach that number, or that number is not included in the solution. Hence, that's why we have parentheses. That's why I said that never assume that if it's a number that it would always have a bracket. A bracket means that it's going to be part of the graph or included in the solution. But if a number has parentheses, that means that the graph will approach to that number but never actually reach it, or the number will not be included in the solution, but a number that is close, another number. For example, if I were to say 5, you can say that 4.99 can be part of the solution, or 4.9999 can be part of the solution, but not 5. So that's what I mean when a number has parentheses. Again, never assume a number always have bracket. A number can have parentheses depending on what type of graph you have and depending on what type of problem you have. So we finished identifying domain, which is open parenthesis, negative infinity, comma, and then infinity with close parenthesis. Now let's do range. Range, we always start from the bottom. So let's take a look at the bottom of the graph. We see that the bottom of the graph is right at the y value of 3. So it pertains to this number from the equation. So that part can help us identify range. So we're always going to start from the bottom. So at the bottom is at 3. So that means that we're going to be using the bracket because 3 is included into the graph, or you say included into the solution. And then comma. Then if you look at the top y value of the graph, so this arrow, these two arrows help indicate that it goes upward forever. So upward forever, that means the positive number. So since it's going upward forever, that means it's going towards infinity. So let's include infinity into our solution or onto our range. And then we're going to end it with parentheses. So there's my range. So it's going to be open bracket 3 comma infinity and then close parentheses. So let's take a look at the right graph. So again, notice how it's going in a different direction. So that's going to affect our domain and range. So let's take a closer look at them. So as always, observe the ends of the graph. So these two have arrows. So that means that some part of it is going to be going forever. So let's take a look. Left side of the graph. So again, it's going in two directions. It's going left forever, and it's going down forever. Then on the right side of the graph, again, it's going in two directions since it's diagonally. So it's going to go right forever, and then it's going down forever. So again, the only thing that's the same were the left and right arrows, but the only difference was the left example has the arrows going up, and then on the right example, it has the arrows going down. So since the left and right arrows are the same, that means probably didn't change the domain. The only thing that changed was the range. So let's take a look at how the range is going to look with this reflection. Now, for domain, pretty much is going to be the same. So on the left arrow, you can see that it's going towards forever. To the left, that means that it's going to go towards negative infinity. So negative infinity, comma, and then as you can see, the right arrow is going towards positive infinity. So we're going to end with infinity, close it with parentheses. So there is our domain. Now let's take a look at our range. So this is the bottom y value of the graph. So since it's at the bottom, and you can see with the arrows, it goes forever downward. So since it's going downward, it mostly involves with negative numbers. So therefore, since it's going downward forever, that means that we're going to start at negative infinity. Or you can say that the bottom y value is negative infinity. So negative infinity. Then let's take a look at the top of the graph. So the top of the graph is right here. So as you can see, it's right at the y value of 3. So similar to this number from the function. So again, that will be helpful for identifying range. So that's the top y value. So therefore, I'm going to put in 3 and then end it with bracket. Because that the 3 is part of the graph or is included into the solution. So if we were to compare the two examples, again, the domain were the same, but the range was different. So here the range is start at 3 and ended with infinity, whereas the range on the right, it start at negative infinity and end at 3. So what were the similarities between these two examples? I would say that the domain for both were the same. Now, what were the differences between these two examples? I would say that left graph went upward, so ended with infinity. Now, for the right graph, so right graph went downward, so started with negative infinity for range. So to review, the domain for these two examples were the same, but for the left graph, it started at 3, which is the bottom, and ended with infinity because, as you can see, it went upward. Whereas on the right graph, see how because of the reflection over the x-axis, it went downward. So it's going to start at negative infinity, and it's going to end at 3, which was the top for the range. So be very careful that if there is a reflection across the x-axis, then it will affect the range. So in layman's terms or overall, if it's reflected over the x-axis and it's a continuous graph, then it's going to start at negative 3. Whereas if there is no reflection, then for a continuous graph, then it's just going to end with infinity. Let's take a look at these next two examples. So we have n of x equal to the absolute value of x minus 4 and then plus 1. Now on the right, we have p of x equals the absolute value of negative x plus 4 and then plus 1. So basically, the graphs were reflected over the y-axis because in the second example on the right, it has a negative inside the absolute value of lines and it's in front of x. So that means it's a reflection across the y-axis. And as you can see, between the two graphs, it did indeed reflect it over the y-axis. So that's the only difference between these two examples. So let's see what happened with the reflection. How did it affect the domain and range? So I'm going to observe the ends of both graphs. As you can see, it has arrows, so it's going on forever. So that means on the left side of the graph, since it's going diagonally, that means it's going in two directions. So it's going left forever, and it's going up forever. Whereas on the right side of the graph, again, going diagonally, so going in two directions, so going forever towards the right, and in addition, going upward forever. Whereas if we look at the bottom of the graph, right here. So again, here's the bottom of the graph at the y value of 1. So we see that the 1 will help us identify range. All right, so we identify all the parts I needed to identify domain range. So let's see if there's any effect with the reflection. So for domain, we're always going to start with the left arrow. And again, it's going forever towards the left. That means that it's going towards negative infinity. So I'm going to start with parenthesis, then negative with the symbol infinity. And then comma. And then if you look at the right arrow, it's going forever towards the right. So that means it's going towards infinity. And I'm going to close with parenthesis. All right, so let's take a look at our range. So let's look at the bottom y value. So the bottom y value is at 1, which again, similar to that 1 we have in the equation. So we're going to end up with, or should I say start with bracket, and then positive 1, comma. Then let's look at the top y value of the graph. As you can see, both sides of the graph is going forever upward. So that means that since it's going forever upward, it's going to go towards infinity. So let's include infinity, and then we're going to end it with parentheses. So here's our range. Now let's take a look on the second example. And just like what I did before, identify the ends of both sides. So it has arrow, so that means it's going forever. So let's draw our arrows. So again, left side going diagonally, so two directions at the same time. Left forever, and then up forever. Now for the right side, same thing, diagonally, so two directions. So right forever, and then upward forever. And then let's not forget the bottom of the graph. So the bottom of the graph is at the y value 1, so ties into this number from the equation. All right, so let's start identifying the domain and range. So domain always starts from the left x value. So let's take a look at the left arrow. It goes forever towards the left. So that means that we're going to start with parentheses, negative, infinity. So let me include this here. And then comma. Then let's take a look at the right arrow. So the right arrow is going forever towards the right. So that means it's going to go towards infinity. And then we're going to close it with parentheses. So there's our domain. Now let's take a look at our range. All right, so here's the bottom of the graph. So the bottom is at positive 1. So we're going to start with bracket, positive 1, comma. And then let's take a look at the top y value. So it's going upward forever. So since it's going upward forever, that means it's going to go towards infinity. So let's include infinity into our range. And then we're going to close it with parentheses. So let's compare the two examples and the two domain and range. So again, we mentioned how the graph reflected across the y-axis. Did that affect anything to our domain and range? So comparing the two, domains are exactly the same. Then looking at the range, the two ranges are exactly the same. So regardless of reflection across the y-axis, with reflection over y-axis, domain and range are same. Let's see, are the same. For the differences between these two examples, I would say that there were no differences for the domain and range of the two examples. I would say that the difference between the two graphs was, as you can see, was the reflection over the y-axis, but overall, there were no differences, no change for the domain and range in terms of reflection over the y-axis. So let's analyze and compare the examples that we've gone through for domain and range. So when I examined all the examples, I noticed that the domains for each of the examples were the same. So let me add that in. So the domain for all examples were the same. It started off with parentheses, negative, infinity, comma, and ended with infinity, close parenthesis. So domain for all examples were the same, negative infinity to infinity. Now, let's talk about the range. The range, I would say that the range was different, were different when reflected across the x-axis, but there were no change. There were no changes when reflected across the y-axis. So that's the one thing I noticed about the range. There were differences when reflected across the x-axis, but there were no changes when reflected across the y-axis. So here below we have two examples where now we have the given equations, no graph, we had to identify the domain range. So upon my what I analyzed is that domain should be the same. So for domain, it would be from negative infinity to infinity. So that would be my domain for the first example. F of x equals the absolute value of x plus 7 minus 3. Now earlier I mentioned about how if we use this particular number in the equation, that can help us identify our range. So let's take a closer look at the equation. Now, it's just the absolute value of x plus 7 and then minus 3. So there are no reflection, so that means that our range is going to start at the number that I circle. So since it's starting at negative 3, we're going to use bracket, open bracket I mean, and then negative 3, comma, and then it's going to end with infinity. So just like all the examples. Now let's take a look at the second example where it's p of x equals the absolute x minus 8 and then plus 4. So again, just like how I said above, the domains are the same. So then therefore, the domain of the second example will be the same as the domain of the first example. And for the range, like I said before, the number that's at the very end right here, the plus 4, that's going to help us to identify a range. So let's take a closer look at the equation. So it's the absolute value of x minus 8 and then plus 4. There are no negative signs outside or inside, so there are no reflection. So that means that the range is going to be similar to the first example. So we're going to start with open bracket, and then based on the number that I circle, we're going to start at +4, comma, and then we're going to end with infinity, and then close parenthesis. So here is the domain and range for the second example. So by following the rules that we've gone through from the examples, we should be able to identify the domain and range with using the given equation and not needed with the graph.